standard reduction potentials on this table. It's a little hard to see, so I'll go back over there. So now we have to figure out, if we see this equation, what's the reaction that's going on at the cathode? First, tell me what's happening at the cathode. Is it an oxidation or reduction happening at the cathode? The reduction is happening at the cathode. Now look at that equation up there and tell me what is being reduced, which element is being reduced in that equation. The iron is being reduced. So we're going to write the half reaction that's balanced. So there were 2 iron 3s, and on the other hand, on the other side, there's 2 iron plus 2s. And how many electrons am I talking about here? 2 electrons. So we have the reduction reaction. Then at the anode has an oxidation going on, and we only have one choice left of what's being oxidized. So we have, and again, balanced, we have 2 I minus, and this is an aqueous solution going to I2 solid plus 2 electrons. So we have now our 2 half reactions written out, and we can look at the potentials for the standard reduction potentials, which we'll need to calculate the E for the cell. So now we want to calculate E naught for the cell, and that's going to be equal to the E for the cathode reaction. And that particular couple at the cathode, we're looking then at iron 3 plus going to iron 2 plus. That's the reduction that's the reduction potential that we're going to be looking up. And then we also need another standard reduction potential, the one for the couple at the anode. And the couple at the anode that we're looking up is I2 to I minus. So if you can see that up there, it's also in your handout. Then we can plug in those values. So for iron, we have plus 0.770 volts minus plus 0.535 volts, and that's going to equal 0.235 volts, which is a positive number. So what would be true about this reaction in terms of it being spontaneous or non-spontaneous? Right, so it would be spontaneous because we have a positive value for delta E, so we'd have a negative value for delta G. All right, so now let's think about what the good oxidizing and reducing agents are here. And let's have a clicker question for that. So which is the better oxidizing agent? Iron plus 3 or I2? And which is the better reducing agent, I minus or iron plus 2? So think about that one. All right, let's take 10 seconds. Very good. So the trick here is to, again, think about these two different potentials. Now, unlike the example we had before, we had a big positive and a big negative value. These are both positive values, but one of them is bigger than the other, and so the better oxidizing one is going to be the one of these two